So exercise 40, question number 9. This particular formula is for the period of a pendulum t. So if I take a pendulum and allow it to swing backwards and forwards, then the period of the pendulum, which is the time for one oscillation, so from start position to full extension one way and then back again, so that is the period of the pendulum for one complete oscillation. Then that depends on the length of the pendulum, which is this term here, this symbol here, L, and G, where G is gravity, 9.81 newtons per kilogram or meters per second squared. So this particular formula allows you to find the period of the pendulum given the length. And what you're asked to do here is to rearrange this formula for L, so we can find what length of pendulum we need for a particular period of time, t. What I'm going to ask you to do when I've gone through this solution is ask you to rearrange the formula for G, for gravity. And then if you want to, as a little exercise, you could use that formula, make yourself up a little pendulum, measure its length, and then calculate the period by allowing it to swing, say 10 times, time it for 10 particular oscillations, and then divide that by 10 to get the period, and then put those figures for the length and the period into the formula you've come up with for G, and you should arrive at a figure of 9.81 meters per second squared. In other words, you've calculated the acceleration due to gravity on this Earth. But anyway, let's have a look at this particular formula, and then maybe you can have a go at the extension activity afterwards. So, well, I'm not going to go through the whole thing, I'm just going to start you off on it. I just want to look at how you start off. I want to isolate the length, and if you look at the formula, it's inside a square root. To get the period of the pendulum t, I divide the length of the pendulum by gravity, then I square root that answer and times by 2 pi. So the first thing to get rid of is the 2 pi. Divide both sides by 2 pi to get rid of the 2 pi on the right hand side, and then so we get t over 2 pi equals root L over G. And now, because the length is inside a root, square both sides. Square both sides to get rid of that square root symbol. So see if you can carry on from there and work out the solution. I'm sure you can get the answer that's in the textbook there. Now the extension activity is to try and rearrange this formula for G, and then once you've done that, if you like to have a go at that little extension exercise, you could try and verify that G equals about 9.81. So rearrange this formula. T equals 2 pi root L over G. Rearrange for G. So this is a little extension activity. I'll put the solution below for G, and then you could see if you can get that answer. Okay, so you should get that G equals 4 pi squared L over T squared. Now you can make yourself a little pendulum, measure L, measure the period T, and then put those figures into this formula to find G.